Your first assignment for this week is to add an operator to this interpreter that I described in the previous videos. To get you started, I'm going to show you how to add a different operator, and hopefully from there you'll be able to figure out how to complete this first assignment. So in order to add an operator to this calculator, we have to make changes in two places. First, we have to update the parser so that it knows what this new operator looks like and how to add it to the parse tree. So the operator that I'm going to add is integer modulus. So we have to add another case to this CalcExpert abstract data type first. I'm going to call the operator, or the tree node for integer modulus, mod. And mod is just like all of these other operators in that it takes two sub-expressions as two arguments. So once we've added mod to the abstract data type, we have to add it to the parser itself. And so we scroll down here to this operations table, which gets passed to this build expression parser function, and we take a look here. And modulus is the same operator precedence as multiplication and division, so we can just add it to this row with the star and slash operators. So it's also a binary operator. The symbol for integer modulus is going to be %, like in C. And then we call this mod constructor that we defined up in the abstract data type. And those two changes are the only changes we need to add an operator to this parser. Once we've added an operator to a parser, let's take a look and make sure that that actually worked. So we can go ahead and run GHCI on this parser module, and that went ahead and compiled successfully. So let's go ahead and give it a sample string to run. So this was parse CalcExpert, I think was the function. We'll go ahead and say for mod 2. And we've got to put a new line on to properly end the expression. And as you can see, after it loads all these packages, down here, it does in fact successfully give us the abstract syntax tree that we want. The operator is mod, and the two arguments are the number 4 and the number 2. So that modification to the parser worked successfully. So next we have to go ahead and add that operator to the evaluation function, which lives here in simplecalc.hs. So we can basically just copy the line for quotient. Instead of quotient, this is called mod, and instead of being the div function, integer remainder, or integer modulus in Haskell, is called rem. And so once we've made that modification, we should be able to run this, and it should work. So we can go GHCI simplecalc.hs, GHCI, not GCHI. And then we can go ahead and call main to start this guy up. That gives us this prompt. So right now the prompt is a caret, or a greater than sign. And that might get changed in the actual version of the assignment you get, but this is in fact running the simple calc program. If we type in 4 plus 2, it says 6. What happens if we type in 4% 2? It gives us 0, which is in fact the right answer for modulus. And we can make sure the modulus works in more complex expressions. Four modulus 3 is 1 times 7 is 7, and that's the answer it gives, so that worked perfectly. And with that, you should be able to complete the first assignment for this week with no problem. Good luck.